Welcome, farmers. Evidently, crops, your main source of income, are very delicate and require much attention when growing. The weather is something that is uncontrollable, and crop yields are dependent on it. What we can do is to predict weather conditions and prepare for it. It will allow you farmers to reduce the impact of natural weather conditions, such as droughts and floods. The weather is split up into 5 elements. They are wind, including the direction and speed, temperature, relative humidity, and precipitation. A good knowledge of these elements will be pivotal to your yield for the year. This video aims to show you how weather can be predicted using simple and basic equipment such as the anemometer, wind vane, maximum and minimum thermometers, sling psychrometer, and the rain gauge. By collecting data from these equipment over a year, a weather profile can then be constructed of your location and also allow for predictions.
Let's start using this instrument. Firstly, the anemometer. An anemometer is used to measure the wind speed. It consists of 4 cups that catch the wind and they spin. As they spin, the ring will move up a vertical shaft that has markings to show the wind speed in meters per second or the Beaufort scale. The reading is at which the ring is at the same level as the marking on the shelf. To use it, stand in an open space with no obstacles to ensure wind flows freely. Hold up the anemometer and keep it at eye level to read the wind speed of the vertical shaft. It is important to keep at eye level with the ring to avoid parallax error. The cups of the anemometer should also be directly facing the wind. Some of the anemometers require a strong wind for the anemometer to actually turn. If not, it will not move at all and the wind speed will be unable to be determined. So, choose an appropriate type to use based on your location. The data collected can be represented in the following table. The data can be interpreted using this table, which shows the Beaufort scale.
A wind vane is used to determine the wind direction. To use the wind vane, just hold it away from you and slightly above your head, ensuring that it is not obstructed. Using a compass, adjust the position of the wind vane according to the compass and wait for the wind to do the magic. It will point to the direction of the wind source. For the data to be accurate, the wind vane has to be placed above ground level at a position where it will not be disturbed by the wind that is deflected from other things. In addition, it should be put in an open space as there will not be objects and buildings in the way of the wind. This will prevent false readings of where the wind is actually coming from due to deflection. Some examples of where the wind vane is used is at airports and for sailing. At airports, wind direction is an important factor for incoming and outgoing planes. However, this equipment has its disadvantages. Firstly, it requires a strong wind for the wind vane to be able to point in the direction of the wind source. If not, it will not move at all and the wind direction cannot be determined. Secondly, it needs to be done in an open space with no obstacles around so as to achieve a precise reading. The data can be represented in a table format. This will make the analysis of data easier.
The maximum minimum thermometer is used to measure the maximum and minimum temperature. There are 2 columns to the analog maximum minimum thermometer. One side is the min, while the other is the max. To know what are the max and min temperatures, the lowest of each point of the metal index indicates these temperatures. The thermometer is placed in a Stevenson screen after being reset by pressing the button in the middle. This will ensure the starting temperatures are the current temperatures. The Stevenson screen is similar to a box with louvered sides, and this is to allow air circulation without any direct exposure to sunlight, to ensure accurate readings. It is strongly encouraged for it to be placed at least 1.5 meters above ground, as the ground absorbs heat radiated from the sun. Hence, holding it above ground will ensure that heat released from the earth will not affect the results of the thermometer. as the expected reading should solely be based on the surroundings. Do remember that there are two types of max-min thermometers, the analog and digital thermometer. As the type of max-min thermometer used is the analog thermometer, it has its disadvantages. The readings can only be read up to 1 degree Celsius. On the contrary, the digital max-min thermometer can read temperatures up to 0.1 degrees Celsius. Hence, the analog max-min thermometer is bound to have some limitations. The data can be collected in the form of a table. To calculate the journal temperature range, also known as the daily temperature range, subtract the minimum temperature from the maximum temperature. To calculate the mean daily minimum temperature, add the two readings before finding the average. Do the same for the mean daily maximum temperature. Expect that this time it will be using the maximum temperatures recorded. To calculate the mean daily temperatures, add up the mean maximum and mean minimum temperatures before dividing by 2. Finally, to calculate the mean temperatures of 3 days, take the sum of 3 mean daily temperatures and divide by 3. We can then interpret the data using this table. Next, the rain gauge measures the amount of rainfall within a certain area.
Firstly, put the rain gauge in an open space. If there is a need to weigh down the bottle, add a few rocks into it. Collect rain in the gauge periodically, ensuring that you record down the amount of rainfall collected every time. To measure the collected rainfall, mark the new height. Use a ruler and record the length of the rain collected. Write down the data onto a table. However, one of the limitations of using a rain gauge is that the bottle might overfill in the case of a very heavy storm. To ensure accuracy in collecting data from the rain gauge, ensure that the starting mark of the rain gauge is flat. Secondly, account for parallax error when using the ruler. Thirdly, place it into the ground with about 30 centimeters protruding, as it will prevent rainfall from splashing, resulting in more accurate readings. Also, remember to put the rain gauge in the open and not under a tree or obstacle. As water on the leaves might drip into the rain gauge, affecting the result. In addition, the rain gauge has to be placed somewhere that is protected from the wind, as the wind may blow the rain past the rain gauge. The data can be represented in the following table. To interpret the data, it can be compared to the official weather statistics. On the other hand, we can determine if the rainfall is heavy or light. Light rainfall is when rainfall is less than 0.1 inches per hour. Moderate rainfall is 0.1 to 0.3 inches per hour, and heavy rainfall is more than 0.3 inches per hour.
Moving on, to measure the relative humidity or RH, we have the sling psychrometer. First, wet the wick of the wet bulb thermometer, ensuring that it's firmly in contact with the bulb. Go to an open space and swing the sling psychrometer for 1 minute at a pace about 2 seconds a turn. Remember to keep it far from your body so it does not pick up your body heat. Water evaporates from the wick as the equipment is swung, and after 1 minute, note and record the temperature on the wet bulb thermometer. Repeat this step until its consecutive constant results recorded. Then record the temperature on the dry bulb thermometer. Ensure that the wick is firmly attached to the wet bulb and that it is in good condition, as frayed wicks would not give accurate readings. Refrain from touching any of the bulbs, as contaminants on our fingers will also change the results. Also, ensure that the wick is wet throughout the entire process, as a dry wick will give a warmer temperature reading on the bulb. Do note that there are limitations, like requiring to face a breeze in order for the psychrometer to work better. Also, swinging the psychrometer might hit things, thus care should be taken when using it. In order to determine the relative humidity, compare the readings to the table of readings for relative humidity, which is attached to every sling psychrometer.
In conclusion, all the information presented here will help all of you in the future. Do remember the steps needed to use each equipment, and remember the ways to ensure accuracy when using these equipments.